The pterosaur is a mystery wrapped in a riddle, wrapped in an enigma. The first pterosaur fossil was discovered just over 200 years ago, and it has been confusing scientists ever since. For the first 20 years after its discovery, it was widely believed to be an aquatic creature that used its uniquely long front limbs as paddles. Even today, there is still very much that is unknown about the pterosaur. We know almost nothing about its ancestry, how it developed the necessary anatomy for flight, or about pterosaur reproduction. In addition, the pterosaur is one of the most prominent prehistoric creatures in popular culture, but it is usually greatly misrepresented. They are almost always called pterodactyls, when in fact the name pterodactyl refers to only one genus of pterosaur. They're usually referred to as dinosaurs, but they're not. Dinosaurs are distinguished by their erect stature, and pterosaurs do not fit this definition. They're usually depicted in films like Jurassic Park 3 and 1 million years BC as having bat-like flimsy wings and powerful feet with opposable digits that allow them to pick things up, when in fact, pterosaur wings were relatively strong, and their feet were weak, and, as you can see in the exhibit above, lacking opposable digits. However, despite this wealth of confusion, there is still very much that is now known about the pterosaur and how it fits into the history of evolution. Approximately 100 species have been discovered, ranging from the size of a sparrow to a small plane. The species you see above you is a relatively average-sized one. There is a great deal of variety among these species. Some had large, elaborate crests, and some didn't have crests at all. Some had teeth, some didn't. Some had long tails, some had short tails, some had no tails at all. The list goes on and on. The most obvious and studied distinguishing characteristic of pterosaurs is their wings. They are the earliest known vertebrates to achieve powered flight. No missing link predecessors have been found, so there is presently no understanding regarding their ancestry. Pterosaurs' development of the necessary anatomy for flight is one of the most remarkable and unexplained phenomena of paleobiology. However, we do know a lot about the nature of their wings. They are very powerful and elaborate and formed of membranes of several different tissues, mostly skin. Primary membranes connected to the extremely elongated fourth finger on each arm and continue down the sides of the body to the legs. This is in contrast to bats' wings, which are supported by 4 fingers each, and birds' wings, which use feathers as their flight surface. The wing membrane was divided into 3 basic parts, all of which you can see in the exhibit above: the propatagium, the brachiopatagium, and the uropatagium. The propatagium is the frontmost membrane, attached between the shoulder and the wrist. The brachiopatagium is the wing's anchor and largest membrane. The uropatagium stretches between the legs. In addition, the pteroid, a bone that appears nowhere else in biology, supports the propatagium by extending between the wrist and the bottom of the wing. In addition, the outer wing was supported by small, tightly spaced fibers called actinofibrils, and the wing housed a complex network of interlocking blood vessels that allowed for circulation throughout the wing. The development of wings wasn't the only way that the anatomy of pterosaurs evolved to achieve flight. Pterosaurs also had very strong, but lightweight bones that were hollow to reduce its weight, but reinforced by internal struts to provide the necessary support. They also had an internal lung air sac system similar to that of birds, which further reduced the pterosaur's overall density. Despite this wealth of knowledge about pterosaur anatomy, there is no scientific consensus on the actual mechanics of pterosaur flight. In the past, some scientists have made calculations using modern birds and determined that pterosaurs were too heavy to fly. However, these hypotheses were based on outdated models of pterosaur anatomy, being similar to that of birds, and are now generally considered obsolete. We now know that pterosaurs were scaled very differently from birds, in such a way that they were able to generate far more power to compensate for their greater weight. Pterosaurs' forelimbs were much stronger than their hind limbs, the opposite of birds, so it is now believed that they used their powerful front limbs to vault off the ground like vampire bats. This method allows most pterosaur species to launch off of any flat surface in a very short amount of time, and achieve great heights almost instantly without special conditions like wind or high cliffs. Scientists are also confused as to how far pterosaurs could actually fly. It was once thought that they could only glide over short distances, but it is now becoming increasingly accepted that they were adapted for active flight over long distances, possibly thousands of miles. This is supported by the fact that pterosaur fossils have been found on every continent. They would have needed to be able to fly over great distances in order to migrate to that degree. This complex blend of anatomical and mechanical characteristics make pterosaurs particularly difficult to classify. For example, pterosaurs and dinosaurs are related and share a unique ankle joint evolved from a common ancestor. However, pterosaurs are not dinosaurs because dinosaurs are distinguished by holes for hip sockets that allow them to maintain a unique upright stance, whereas pterosaurs' hip sockets are merely shallow cups. It is also now accepted that neither birds nor bats evolved from them. Their wings are an example of convergent evolution. Until recently, some scientists believed that pterosaurs went extinct because of competition with early bird species. But now it is widely accepted that all pterosaurs died in the KT extinction 65 million years ago. That also killed the dinosaurs and roughly 50 to 75% of all species in existence at that time. Classification and analysis of the evolutionary relationships of the pterosaur becomes even more difficult when examining some of its other characteristics. Most pterosaur groups had elongated jaws, similar to the beak of a bird. Most, but not all, had teeth. Paleobiologists believe that pterosaurs fed on a diet of mostly fish, judging from the fact that fish have been found in the stomachs of some pterosaur fossils. But it is not clear how pterosaurs used their bird-like jaws to eat, as birds lack teeth and therefore do not compare well to early pterosaur species. Many pterosaurs had elaborate crests that were often extended by keratin or other soft tissues. Further adding to the confusion, some pterosaurs developed odd, fur-like filaments over their skin known as pycnal fibers. This stands in stark contrast to other reptiles, which have scales. It suggests that pterosaurs may have been warm-blooded like mammals. Since pterosaurs and mammals are obviously not closely related, this is yet another example of convergent evolution. All of this makes it extremely hard to classify pterosaurs. They are generally accepted to have been diapside reptiles. However, there is much debate over whether they should be classified as dinosauromorphs or archosauromorphs. Pterosaurs share some traits in common with both groups, including ankle joints similar to dinosauromorphs and neck structures similar to that of the archosauromorphs. This issue likely won't be settled for many years. The relationships between different pterosaur groups have also yet to be definitively established, although fossil discoveries within the last decade have filled many gaps that have confounded paleobiologists before. The pterosaur is both one of the most fascinating and complex creatures of the prehistoric Earth. It is one of the most popular and culturally emphasized prehistoric animals, yet many of its defining characteristics are widely misunderstood or unknown. Its highly unique anatomy and position as the first known vertebrate to achieve flight makes it one of the most interesting topics of evolutionary study. But scientists still are clueless as to what species pterosaurs evolved from and the process by which it happened. In addition, pterosaurs possessed a complex blend of characteristics that seem to have been mixed and matched from different evolutionary groups, making their classification even more difficult. The only thing we can know for certain about the pterosaur is that the same characteristics that make it such a mystery will continue to make it a focus of paleobiological study and a cultural mainstay for years to come.